Alright, the final objective for part 2 of graph transformations, quadratic graph transformations, is a vertical stretch slash flip about the x-axis. It says 2 parts, so just pay attention to both parts and how they affect the parent graph y equals x squared. So I'm going to put that, just make note of that up here, y equals x squared, the parent function. So, investigation number 5. It gives you the equation y equals 2x squared. So if you notice, the big difference here is the parent function has a coefficient, an a term. Remember, whatever term exists before the quadratic term is technically considered the a term. So the a term in this has gone up. It went from 1 from the parent function to 2, the given function. So technically there's a number being multiplied to my function now. So that is going to affect all of my y values. Pay attention to all of my y values, all right? When I do the table of values, they are going to change. So that's also going to affect my step pattern in this case. Because we can still, I'm going to plot the vertex and then use the step pattern to plot my graph. I'll fill in the tables just so you can see what's exactly happening, but finding the vertex and using the step pattern is probably the best way to go about drawing these graphs. So the vertex, again, formula, y equals x minus h squared plus k. So I need to look for an h and a k. In this case, my given equation, here's my power. There is a number to the left of the power, but technically this 2 would be right here in this equation. So to the left of the power, it still needs to be, to affect the x value of the vertex, it still needs to be paired with the x inside parentheses. So this does nothing to my x value. So that still means that the vertex of this function is 0 for my x value because there's no h value there. There's no h number paired with the x. And then k as well. To the right, there's no k. So that means that my y value is also 0. So this graph starts at 0, 0. That is my vertex. So I have found the vertex. If I plot that vertex at 0, 0, that's my initial starting point. I have to also consider, is this a positive or negative function? The 2 is positive, so I know that the direction of opening is going up. So I'm going north, vertical. And this is the vertex 0, 0. So I know that my step pattern is going to be going up. Remember, if it's positive up, negative down. So I'm going to hold off on the step pattern just to show you what actually is happening to my y values because they're being multiplied. They're all going to be inputted into this function, but then they're all going to be multiplied by the number 2. So they're going to be bigger than the original parent function. So if I put a negative 1 in there, let's say y equals 2 times a negative 1 squared. So negative 1 squared is 1, 2 times 1 is 2. So negative 1 I'm going to plot over and up 2. Hopefully you're comparing to the original function. Negative 1 is going into the original parent function up here. I'll rewrite it up here too. Y equals x squared. If I put a negative 1 into here, negative 1 squared is 1. So it would be negative 1 comma 1, which would be right there. So it's already getting taller. If I put a negative 2 in there, y equals 2 parenthesis negative 2 squared. Again, all I'm doing is I'm inserting this into my function, the variable of the function, and I need to put it in parentheses, or you might come out with the wrong answer because it's negative. Negative 2 squared is 4, positive 4 times 2 is 8. So I go over to negative 2, I'll continue in green, up to 1, 2, 3, 4, 5, 6, 7, 8. And then finally, negative 3 squared, y equals 2 parentheses negative 3 squared. And that equals, negative 3 squared is 9 times 2 is 18. So 18 is somewhere negative 3 all the way up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, somewhere up here. So 1 will give me the same as -1, 2 will give me the same as -2, and 3 will give me the same as -3. So I can plot the same things over here. 1, 2, 2, 8, and 3, 18, somewhere up there. I'm just going to draw this part of it though. Alright, that is y equals 2x squared. So if you're going to notice the step function, we go from the vertex. Let's draw that now. From the vertex. I go over to the right one, up 2. Same thing, over to the left one, up 2. And then from this dot, over 1, up 1, 2, 3, 4, 5, 6. And then finally, over 1, up. From this point, that's... So this is at 8 over 1, this is at y equals 8 right here. And I'm going up to 18. 18 minus 8 is up 10. Now, if you remember from the parent function of y equals x squared, its step pattern, the step pattern there was over 1, up 1, over 1, up 3, over 1, up 5. So I need you to be able to see that what is truly happening to all the y values in this function, this given function y equals 2x squared, all the y values are double what the parent function y values would be. If you remember, the parent function I'll draw in red is 0, 0, over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 1, over 1, up 3, over 1, up 5. This is my parent function. So all of the y values, the x values are still the same. But my y values, because it's being multiplied by a factor of 2, all of my y values have doubled. So if you want to use the step pattern for anything that has a number here, an a coefficient greater than 1 being multiplied, you have to know that the y values are going to increase by that factor. So in this case it's a 2, so they've been doubled. Every y value here has been doubled. This was 1, now it's 2. This was 4, now it's 8. So every y value is doubled because it's being multiplied by a factor of 2. Go ahead and try this one now. See what happens by inserting the x values into the function. Be concerned with the direction of opening. And notice that it is negative. So that should tell you that it's going to open not up, but down. It's going to make a frowny face. Go ahead and try these and then test out the step pattern. See what happens. When you're done with this, raise your hand and we're going to talk about it a little bit. You can plot the points, but you can also find the vertex as well.